In this class, we're going to go over calculation on soil physics. Okay, let's take the question. A sample of soil with a wet mass of 1.0 kilogram and a volume of 0.64 liters was dried in the oven and found to have a dry mass of 0.8 kilogram. From the given data, calculate the bulk density in gram per centimeter cube of the soil. And question B, we are asked to calculate the moisture content of the soil in the feed on mass basis in percentage and on volume basis in percentage. Then question C, assuming the typical value of the particle density for a mineral soil is 2.65 gram per centimeter cube, we are asked to calculate the total pore space of the soil in percentage, and we are asked to calculate the void space within the soil in percentage as well. Okay, then question D, we are asked to calculate the degree of saturation. Now please, I want you to pay attention. I'm going to take it step by step. You just have to follow the calculation. Okay, let's start by writing out the information that we're given in the question. We are given that a sample of moist soil with a wet mass of 1.0 kilogram. That means that the wet soil is what? Wet soil is 1.0 kilogram. You understand? Okay. And we are given that the volume is what? 0.64 liters. Okay. 0.64 liters. Volume equals to 0.64 liters. But this liters and meter cube is what? 6.4 times 10 raised to power negative 4 meter cube. You understand? Okay. Now, this soil was dried in the oven and found to have a dry mass of 0.8 kilogram. So the dry soil, you understand? Let me just put like that. Dry soil. The dry soil is 0.8 kilogram. Now let me quickly explain this. The reason why the weight of the wet soil is higher than the weight of the dry soil is because having been oven dry, the water content was removed. You understand? The water content of the soil plus the mass of the soil is what makes 1.0 kilogram. You understand? The water content of the soil. Wet soil contains of soil and water. You understand? So the water content of the soil and the mass of the soil makes the weight of the wet soil higher than the weight of the dry soil. Now, when the soil is being oven dry, the weight is reduced to 0.8 kilogram. You understand? That is, having been oven dry, the water content is removed. Are you paying attention? Okay, now we are asked to calculate the bulk density in gram per centimeter cube. So, the first parameters we are asked to calculate is bulk density. Let me just call it BD. You understand? We are asked to calculate it in gram per centimeter cube. Gram per centimeter cube. Okay? Now, since we are asked to calculate the bulk density in gram per centimeter cube, if you pay attention to the units that we are given in the question, the parameters that were given in the question are in kilogram. You understand? For example, the weight of the soil is in kilogram, and as well as the volume is in meter cube also. Meter cube. Okay? Now, we have to first change the parameters to gram and the volume to centimeter cube. We have to change the weight to gram and the volume as well to centimeter cube. Do you understand? That is the first step. So, the wet soil in gram will be equals to, now don't forget that from your basic unit measurement, 1000 gram equals to 1 kilogram. You understand? Do you understand? So let's say x gram equals to I'm doing here is that I want to change this 1 kilogram to gram. You understand? And the reason why I'm showing this is because I want you to understand. If I'm doing this in the exam, all I have to do is just multiply this 1 kilogram by 1000. I'm going to get it in gram. Okay? So x gram, let's say x is equals to 1.0 kilogram. You understand? So x is equals to, if this multiply this and this multiply this, I'm going to have 1000 gram multiplied by 1 kilogram, and this 1 kilogram will also multiply what? 1 kilogram multiplied by x. What I did is that this 1 kilogram multiply this x, I have 1 kilogram times x, and this 1000 gram multiply this 1.0 kilogram, then I have 1000 gram multiplied by 1 kilogram. Now divide both sides by 1 kilogram, this over 1 kilogram. So this will cancel this, you understand? And this will cancel this. So I'm having x is equals to 1000 gram, you understand? So with the wet soil in gram is what? 1.0 kilogram. Okay, 1.0 multiplied by 1000. So that will give me 1000 gram. You understand? I just showed you this this solution so that you will not say, where do I see 1000? You understand? 1000 gram equals to 1 kilogram. Okay, so I changed this wet soil from kilogram to gram. Now let us change the dry soil as well. The dry soil in gram will now be equals to 0.8 multiplied by 1000, which will give us what? 800 gram. You understand? Okay, now let us change the volume from meter cube to centimeter cube. You understand? Because we are asked to determine the bulk density in what? In gram per centimeter cube. And we have already changed the weight. We have already changed the mass to gram. And now I have to change the volume from meter cube to what? To centimeter cube. Now, the volume in cm cube will be equals to, now I want to do some arithmetic here and I want you to pay attention. Do you understand? You know, 6.4, pay attention. 6.4 times 10 raised to the power of, please pay attention. 6.4 times 10 raised to the power of negative 4 can be written as, I'm going to have 1, 2, 3, 4. You understand? It can be written as 0.00064. 0.00064. That is, when I change it from standard form to decimal form. You understand? That is 1, 2, 3, 4. You understand? Now, 6.4 times 10 raised to negative 4 can be written as this. And this is the meter cube. Pay attention. This is the meter cube. Now, I just changed this from standard form to decimal form. You understand? I just want to perform some arithmetic. You understand? Okay? Don't forget, from your unit measurement, 10 millimeter equals to what? 1 centimeter. 10 centimeter equals to what? 1 decimeter. 10 decimeter equals to what? 1 meter. Okay? Now, that means that 100 centimeter equals to what? 1 meter. Please, are you paying attention? If you didn't understand, study your unit measurement. The reason why I'm showing this step is that I want you to understand, okay? Now, the reason how I got 100 centimeter is because I multiplied 10 by 10. You understand? If I want to convert centimeter to meter, that means I'm going to multiply 10 times 10. That is 100. That means that 100 centimeter equals to what? 1 meter. Now, but I am dealing with meter cube. So I'm going to cube both sides, okay? I'm going to cube both sides. So, if you don't know how many centimeter equals to 1 meter cube, you are going to know from here. Here, I'm going to have 100 centimeter multiplied by 100 centimeter multiplied by 100 centimeter. That will be what? 1 meter times 1 meter times 1 meter. You understand? Now, 100 times 100 times 100. That will give us 1 million. You understand? So, I'm going to have 1 centimeter cube equals to 1 meter cube. Do you understand? So that is how I got this. Now you know that 1 million centimeter cube equals to 1 meter cube. All you have to do now is that let x centimeter cube, let x, just put x, okay? Let x equals to 0.0064 meter cube. 0.00064 meter cube. The goal is to convert this meter cube to centimeter cube, like we did for the masses. You understand? Okay? So for this, I'm going to have, if this 1 million centimeter cube multiply this x will multiply 1 meter cube. So I'm going to have x multiplied by 1 meter cube equals to 1 million centimeter cube multiplied by 0.00064 meter cube. Do you understand how I got here? If you didn't understand, reverse the video and listen to the explanation again, okay? So, the next step here is that I'm going to take the product of, okay, let us first divide both sides by meter cube, 1 meter cube, okay? This over 1 meter cube. This, we cancel this, so I'm left with what? X equals to, this also, this meter cube, we cancel this meter cube. So, I'm left with what? 1 million centimeter cube multiplied by 0.00064 Oh yeah, what's the answer? That will give us 640 centimeter cube. So I'm going to have 640 centimeter cube. If you point your calculator, you're going to have this. Hence, the volume in centimeter cube is what? 640 centimeter cube. Do you understand? You can see the long process. I just showed you that long process. If I'm dealing with this in exam, I'm not going to go that far. You understand? I'm just going to say let 1 million centimeter cube equals to 1 meter cube. So let x equals to 0.00064 meter cube. So I'm going to cross multiply so that the examiner will not say that how do I got 640 centimeter cube. Do you understand? I'm not going to go this long way. You understand? I'm just going to take this and this. But the reason why it goes this long way is because I want you to understand that 1 million centimeter cube. So if you do, peradventure, if you don't remember your measurements, just remember this, and then you'll be able to draft out how many centimeter cube make 1 meter cube. Okay. Now we have already converted all the parameters to gram and centimeter cube. Now the next step here is that we're going to proceed to calculate the bulk density. But before we proceed, what do we mean by the soil bulk density? Bulk density refers to the mass of the soil per unit volume. You understand? That means the mass of the soil all over volume will give us the bulk density of the soil. So bulk density equals to mass of the soil, which is ms. Are you paying attention? That is the dry mass. Okay, are you paying attention? The dry soil is ms. Now the mass of the soil all over the volume. You understand? Do you understand? All over. Let me just put it total volume. Okay. Now the mass of the soil is what? 800 kilogram. 800 gram. You understand? Don't use 0.8 kilogram. Because the question says we should calculate the bulk density in gram per centimeter cube. So I'm going to use 800 gram all over. The volume that we got is what? 640 centimeter cube. You understand? Okay, 800 divided by 640. That means the bulk density of the soil, BD, equals to. Now, if you punch your calculator, you're going to get 1.25 gram, 1.25 gram per centimeter cube. You understand? That is the bulk density of the soil. Trust you understand. Okay, now having gotten the bulk density, we are asked to proceed to calculate the moisture content on mass basis. You understand? Okay, now let us determine the moisture content on mass basis. Please, I want you to pay attention. The moisture content on mass basis, MC on mass basis, equals to the mass of water all over the mass of the soil. Because we are asked to calculate it in percentage, you have to multiply it by 100. You understand? Okay, now we have to determine the mass of water. Even though we've known the mass of the soil, the mass of the soil is the dry soil. The mass of the soil is 800 grams. You understand? So the mass of the soil equals to 800 grams. Now to get the mass of water, we have to subtract the wet weight, the wet weight minus dry weight. You understand? Don't forget, when I begin, before I calculate the bulk density, I told you that wet soil consists of the mass of the water and the mass of the soil, but the dry soil contains only the mass of the soil. You understand? Having oven dry the wet mass, the wet weight, or the wet soil, having oven dry it, the water content evaporated. You understand? So we lose the water content, so the mass is reduced to what? 800 grams. That is what we call the mass of the soil. Now to get the mass of water, we have to subtract the wet soil from the dry soil. The wet soil in gram is what? 1000 grams. So I'm going to have the mass of water equals to the wet weight minus the dry weight. You understand? So the wet weight is what? 1000 grams. 1000 grams minus the dry weight. The dry weight is what? 800 grams. You understand? 1000 grams minus 800 grams. That will give me 200 grams. So therefore, the mass of water is what? 200 grams. Do you understand? Okay. So now I can proceed to calculate the moisture content on mass basis. That will be the mass of water, which is 200 grams, all over the mass of the soil, which is 800 grams, multiplied by 100. Okay. So for this, I'm going to have this gram will cancel this gram. Hence, I'm going to have 1/4 multiplied by 100. You understand? So 1/4 multiplied by 100 will give me 25. Hence, the moisture content of the soil on mass basis is what? 25%. You understand? You might come across some questions that say you should calculate the moisture content gravimetrically. Gravimetrically simply means on mass basis. You understand? So whether they put on mass basis or gravimetrically, just know that the question is still the same. Just calculate it on mass basis. Okay? So let's proceed to the second question under question number 2. We are asked to determine the moisture content volumetrically. The moisture content on volume basis is given by this formula. Moisture content on volume basis equals to the volume of water all over total volume. You understand? Because we are asked to calculate it in percentage, we have to multiply by 100. Okay? So now the volume of water we are not given in the question, but we know that total volume is what? 640. Total volume equals to 640 centimeter cube. Now, in our previous calculation, we determined the mass of water, right? So the mass of water, let me just put it here. The mass of water, please pay attention, equals to what? 1000 gram. Don't forget, minus 800 gram. Do you remember? That is 200 gram. The reason why I write it in this place is because I'm going to need it. You understand? So the volume of water, how do we calculate the volume of water? That is the big question now. Just pay attention, okay? To calculate the volume of water, we have to use the density of water. The density of water is constant. Just pay attention. I'm going to explain, okay? Now, I want to determine the volume of water because I cannot determine the moisture content on volume basis without knowing the volume of water. You understand? Now, the volume of water will be gotten from the density of water. The density of water is constant. You understand? The density of water density equals to 1 gram per centimeter cube is constant. You understand? So, and if you look at the unit is what? Gram per centimeter cube. So, the formula for calculating the density of water equals to what? Mass of water all over what? The volume of water. You understand? You see, this is simple. When you begin to understand the unit that the density of water carries, you will remember the formula. You understand? Density of water is constant. It is what? 1 gram per centimeter cube. Gram means mass and centimeter cube means volume. You understand? And this is the density of water. So it will be what? Mass of water all over the volume of water. Now, from this formula, I'm going to determine the volume of water. You understand? The density of water is constant. So 1 equals to mass of water. Mass of water is already calculated. That is what? 200 gram. So I'm going to have 200 gram all over volume of water. I don't know the volume of water. That is what I want to determine. So I'm going to put it here. Volume of water. Now, from here, we are going to cross multiply. Volume of water multiplied by 1. That is where I'm going to have VW, which is volume of water. 200 gram multiplied by 1. That will give me 200. So, since volume is in centimeter cube, so I'm going to have 200 centimeter cube. That is the volume of water. Do you understand? Okay? Having gotten the volume of water, we can now proceed to calculate the moisture content on volume basis. We just have to substitute all we have got into the formula above. So, moisture content on the basis of volume is equals to volume of water 200 centimeter cube all over the total volume. The total volume is 640. You understand? 640 centimeter cube multiplied by 100. You understand? See, the volume of water is what? 200 centimeter cube. The total volume is what? The total volume is 640 centimeter cube. You understand? Multiplied by 100. So the moisture content is equals to 200 divided by 640. That will give me 0.3125. Hence, I'm going to have 0.3125 multiplied by 100. You understand? This will give me 31.25%. Okay? 31.25%. Do you understand how we got the moisture content on volume basis? If you didn't understand, reverse the video again. Okay? So now, having gotten the moisture content on volume basis, let us calculate the total pore space. Before that, what do we mean by total pore space? Total pore space is the space in the soil that is occupied by water and air. You understand? Total pore space refers to that space in the soil that is occupied by water and air. I'm going to explain. Just pay attention, okay? Now, how do we calculate the total pore space? Don't forget that we are given that the particle density is equals to 2.65 gram per centimeter cube. The particle density, let me just put it here. The particle density equals to 2.65 gram per centimeter cube. Okay, please just pay attention. Okay, just pay attention. You're going to understand. We're going to make use of the particle density to determine the total pore space. That's why they give us that parameters in the question. Okay, so the total pore space is given by this formula: 1 minus bulk density all over particle density. The total pore space, let me just put it, is equals to 1 minus bulk density all over particle density. Okay, so the pore space is equals to 1 minus, what is the value of the bulk density that we got? The value is what? 1.25. You understand? So 1.25 all over particle density. The particle density is what? 2.65. Okay, all over 2.65. You understand? Okay, pore space equals to 1 minus 1.25 divided by 2.65. That will give us 0.4717. Okay, 0.4717. Hence, pore space, the total pore space equals to 1 minus 0.4717. What's the answer? That will give us 0.5283. Okay, 0.5283. You understand? So if you want the total pore space in percentage, okay, let me just put it. The pore space in percentage equals to 0.5283 multiplied by 100. If you are solving this in exam, that's how you are going to put it. The total pore space equals to this. Then you cannot put it in percentage by multiplying it by what? 100%. And you must make sure that you put this. The total pore space in percentage is equals to 52.83%. You understand? Okay. So let us calculate the void space. The void space. What do we mean by void space in soil physics? Void space refers to all the empty spaces in the soil. You understand? Including the pore space. You know, pore space is the space in the soil which is filled by what? By air and water. You understand? But void space is the larger terms. Void space refers to those spaces in the soil that is empty, including the pore space. Okay, the void space refers to all the empty spaces in the soil, including the pore space. It refers to the volume within the soil that is not occupied by solid particles, regardless whether it is filled with water or it is empty. Do you know the meaning? This implies that, let's say this is a soil. Okay, let's say we have a soil. We have soil. You understand? Please pay attention. Let's say we have soil here. You know that there are some spaces. Let's say half of this soil is occupied by water and air. You understand? And because this place is solid, of course, no matter how solid a soil is, there will still be some spaces. You understand? So because this space is solid, even though it is not occupied by water or air, this combination of this space in the soil and this space in the soil is what we call void space. You understand? So you understand it is the larger, the void space is the larger terms. It encompasses both the pore space and those space that is not occupied either by water or air. You understand? Okay? Please kindly pay attention. The void space is equals to particle density all over bulk density minus 1. Okay? So particle density is what? 2.65. So 2.65 all over bulk density 1.25. 1.25 minus 1. You understand? So 2.65 divided by 1.25. That will give us 2.12. Okay, no, 2.12. You understand? The numbers after the decimal point are called individually. You understand? So 2.12 minus 1. 2.12 minus 1. So that will give me 1.12. You understand? You can change it to the to percentage by multiplying it by 100. You understand? Do you understand what I did? You can change this to percentage by multiplying it by 100. Okay? That means we are going to have the void space. Okay? The void space in percentage equals to 112%. You understand? If you multiply 1.12 by 100, you're going to get 112. Okay, so that is the void space. Now we've determined the total pore space and the void space. The next question says we should calculate the degree of saturation. Okay, now how do we calculate the degree of saturation? In fact, what do we mean by degree of saturation? The degree of saturation in the soil refers to the fraction or percentage of the pore space in the soil that is filled with water. You understand? Don't forget that pore space refers to those spaces in the soil that is filled with either air or water. Okay? Now, that fraction of the soil that is filled with water is what we call the degree of saturation. Of course, saturation tells us how something is being occupied by water. You understand what I'm saying? How the soil is occupied by water. That's what we call the degree of saturation. You understand? Okay? Now, how do we calculate the degree of saturation? The degree of saturation is given by this formula. The degree of saturation equals to the volume of water all over the total volume minus the volume of the soil. You understand? The volume of water all over the total volume minus the volume of the soil. I'm going to explain, okay? Don't forget that the volume of water is equals to what? 200 centimeter cube. Volume of water equals to 200 centimeter cube from our previous calculation. You understand? And the total volume is what? 640 centimeter cube. The total volume VT equals to 640 centimeter cube. Now, we don't know the value of Vs. How do we calculate the value of Vs? We can determine the value of Vs from the particle density. You understand? The particle density is given by what? The particle density equals to 2.65 gram per centimeter cube. Now, if you look at the unit of this particle density, it is gram per centimeter cube, which means it is mass all over volume that gave us the particle density. And the particle that we're talking about in soil physics is what? The soil itself. You understand? So the particle density 2.65. Okay, let's take it step by step. The particle density is equals to mass of the soil all over the volume of the soil. You understand? Okay, the particle density is equals to 2.65 equals to the mass of the soil. The mass of the soil is the dry soil. The dry soil is what? 800 grams. So I'm going to have 800 grams all over the volume of the soil. You understand? In this case, I'm going to cross multiply. So I'm going to have the volume of the soil multiplied by 2.65 equals to 800 grams multiplied by 1. 800 grams multiplied by 1 will give me what? 800 grams. You understand? So I'm going to divide both sides. 2.65 by 2.65. Okay? Oh, sorry, 2.65, not 26.5. 2.65. Let me change this marker, okay? Please, just pay attention, okay? You're going to understand. Now, I'm going to divide both sides because I want to determine the volume of the soil. So this will cancel this. So I'm going to have the volume of the soil is equals to 800 grams divided by 2. Oh, sorry, this is 2.65. Oh, okay? This is 2.65. Okay? This is 2.65. Now, 800 grams divided by 2.65. That will give us 301.8868. 301.8868. You understand? Let me calculate it. Yes, 301.8868. Now, having gotten the volume of the soil as 301.8868, we can determine the degree of saturation because we have all the parameters that we need in the formula. You understand? The degree of saturation will be equals to the volume of water, which is 200 centimeter cube, all over the total volume, which is 640 centimeter cube minus 301.8868 centimeter cube. Let me quickly give you a hint. You can approximate to 2 decimal places. You understand? It's because I'm teaching you. That's why I leave it at 4 decimal places. Okay. So for this, I'm going to have the degree of saturation. The degree of saturation. The degree of saturation is equals to. Now, that will be 200 centimeter cube all over 640 minus 308 301.8868. That will give us 338.1132 centimeter cube. Now this will cancel this. So the degree of saturation is equals to 200 divided by 338.1132. That will give us 0.5915. 0.5915. So the degree of saturation in percentage will be 0.5915 multiplied by 100. That will give us 59.15%. You understand? That is the degree of saturation in percentage. Because you understand the solution to the question, that is the right solution. Okay, so let's have another past exam question. This is for 2017-2018. A sample of moist soil with a wet mass of 1.0 kg and a volume of 0.64 liters was dried in the oven and found to have a dry mass of 0.8 kg. Assuming the typical value of the particle density for a mineral soil is 2,650 kg per meter cube, calculate the following with the appropriate units. We have the bulk density, the porosity, the void ratio, the gravimetric water content, and the volumetric water content. Okay, you can see that this question is similar to the previous question that we solved. That is for 2019-2020. You understand? Okay, to watch the solution to that past exam question, kindly check the link in the description of this video. Okay, so don't forget to engage the video by liking and dropping comments. If you didn't understand anything in this video, kindly let me know in the comment section. Okay, see you in the next. To watch the next class, kindly check the description of this video. You are going to see a link there. Click on that link, or you should check the playlist on this channel. Okay, see you in the next class.